Hey scholars, it's Mrs. Gregerson, and we are doing the last section from lesson 9.5 for regulars, and this would be the second to last one for honors. And it's the trig and area, like how do we use trigonometry to find area for regular polygons and triangles. And the cool thing is it works pretty well, but the key is you still have to know your ratios. Bless me. Okay, so the first one, remember, is that our sine of an angle is always going to be opposite leg over hypotenuse, okay? And we always need to remember everything's based off of the acute angle. And then we had our cosine of an angle is going to be adjacent leg over hypotenuse. And then we had the tangent of an angle equals opposite leg over adjacent leg. So those will be our basis that we do everything. But we also have to remember stuff from our previous chapter 7. So we have had chapter 8, but we also need to know chapter 7. Remember, a regular polygon's area is 1/2 apothem times perimeter, or you could say area equals apothem times perimeter over 2. Remember, A is your apothem, and P is the perimeter of the polygon. And then we also have the area of the triangle, and that formula does not change. And the area of the triangle is just base times height over 2, or you could say area equals 1/2 base times height. Well, what I'm going to do now is I'm just going to work 4 problems solving for the area of a regular polygon. And they're not going to be real easy. They're going to take time, and there's lots of detail. But a few key things with this. First of all, do not, punch things into your calculator until the end. Otherwise, it gets really messy, and it doesn't help as much. So let's start right away working with a regular polygon. Now remember, regular polygons, all the sides and all the angles are the same. And the first thing you always do is you draw your central angle triangle. Okay, so we have our central angle triangle. So with that central angle triangle, remember the few different parts that we have. We had the 2 radii, which are the same. We had our apothem, which will bisect our side. We had our side length. And we had right here our central angle. Okay, so the central angle was formed by the 2 radii. All right, what do we have to do first? Well, let's label this. It says find the area of a regular pentagon with 8 centimeter sides. So I know this is 8 centimeters, but what does the apothem do to that side? Bisects it. Excellent. So I know that would be 4 centimeters. Now I have to always find the central angle. It's going to be the key with this one. So central angle. So remember, we take 360 and we divide by the number of sides. And this is a pentagon, so remember it has 5 sides. So 360 divided by 5 is going to be 72 degrees. But the apothem bisects it, so I know this would actually be 36 degrees. Okay? With that, sorry that my phone just went off and it totally threw me there. Now I can solve for the apothem. That's what I was trying to say. All right, now I'm going to find my apothem. Well, I can now look just at the triangle here, okay, the leg. So when I have the triangle, I have my acute angle, I have my opposite and adjacent. I'm going to use tangent to solve for it. So I have the tangent of 36 degrees is equal to opposite over adjacent, so 4 over A. Now what's going to happen here? Well, I know, because this is the bottom of my denominator, I can switch my extremes and get back that A equals 4 divided by the tangent of 36 degrees. So that's my apothem. But I still have to find the perimeter. Alright, so if I'm going to find perimeter, okay, you're going to have to take the side length times the number of sides. So perimeter is just going to be here, in this case, 5 times 8. Which is 40 centimeters. So, okay, so there's my apothem, there's my perimeter. I now can punch this into my calculator. So we write our formula down just like before. It's 1/2 apothem times perimeter. So we go 1/2. My apothem is 4 divided by the tangent of 36 degrees. And my perimeter is 40. Now, I think it's faster to go ahead and simplify before we work with it. So I go 1/2 of 4, which is 2, and then I get 2 times 40, which is 80, divided by the tangent of 36 degrees. I think that's easier to punch into the calculator for me. So I go over here, and I just go, all right, 80 divided by the tangent of 36, what do we get? 110, and we want this to the nearest tenth, okay? So when we work with these nearest tenth, 0.1 square centimeters. Now, how about if I didn't want to enter it in like this? What if I wanted to go straight from here? Here's one way of doing it. I think it would work. Instead of 1/2, go 0.5. So 0.5 times, and I'd literally do the parenthesis here, 4 divided by the tangent of 36, close the parenthesis, times 40. Notice you get the same thing. So there's more than one way of doing it. Another way, you could find 4 divided by the tangent of 36. Take that, multiply it times 40, and then multiply that times 0.5. I mean, you're still going to get the same value. So it's still 110.1 square centimeters. All right, now let's do the next one also. Okay, it says find the area of a regular octagon with a radius of 16 meters. Well, an octagon has 8 sides, right, like an octopus. But we still do the same thing like we did before. We will always draw your central angle triangle. So central angle triangle. So radius, radius. Okay, our apothem is going to come down. We have our side, which we don't know the length, and I had someone ask me if that was an S today. Yes, that's an S. I put a curly Q on my S's. That's not a 5. My radius, okay, is 16 meters. But the first thing I always will do is I'm going to still find the central angle. All right, so when I find the central angle, I'm going to go 360 and divide by 8. Well, what is 360 divided by 8? All right, that's going to be 45. All right. However, what does the apothem do to your central angle? Yeah, bisects it. So I know this angle is actually 22.5 degrees. Now I can use that to solve for my apothem because I have the smaller right triangle, and it's going to be cosine because I have the hypotenuse, I have the adjacent leg. So I'm going to go the cosine of 22.5 degrees equals adjacent over hypotenuse. So that's 16 there. Okay? So I go 16 times the cosine of 22.5 degrees is going to equal my apothem. So the cool thing is that's all taken care of. But I still have to find the perimeter. So this was my finding A moment. Okay, we had central angle, find A. We have to find the perimeter. Actually, let's go back in blue in this one. Let's find P. Now this is going to take a little more work, but not as bad as it thinks. We're kind of going to ignore the fact we know A. But I do know that it will divide that side in half. So I'm going to call this X. And I'm going to solve for the missing side. And then I'm going to have to double it to get the side, and then I'm going to have to multiply by 8 to get the whole perimeter. So let's just do one part at a time. Let's solve for X first. Well, that's going to be sine this time. So I get the sine of 22.5 degrees is going to equal opposite over hypotenuse. Then I multiply by 16, so I get the sine of 22.5 degrees, which equals X. But now I have to actually calculate the perimeter, and I'm actually going to go backwards. All right, what do I have to do to get the whole side? Well, the whole side is 2 times X. So I'm going to go 2 times 16 times the sine of 22.5 degrees. But I also have 8 sides, so I have to multiply that by 8. So when I do, I end up getting 256 times the sine of 22.5. All right, so that's our perimeter. But now we can calculate area. Okay? Now, how are we going to do that? All right, because we found the central angle, we found A, we found P. Now we just put it in our formula. We have 1/2 apothem times perimeter. So I'm going to have my 1/2, or you can put 0.5 down. I'm going to put my apothem, which is this one right here. So I get times 16 times the cosine of 22.5 degrees times the perimeter, which is here, this one. So it's going to be 256 times the sine of 22.5. Now this is all about punching this into your calculator, and it's actually not that bad, especially if you change 1/2 to 0.5. So we go 0.5 times 6, oops, make sure I go back, 16 times the cosine of 22.5 times 256 times the sine of 22.5. Hit enter, and you should get, if you round to the nearest tenth, 724, let me move this down so you can see a little bit more, 0.1. So here we go. We get 724.1 square meters. All right, guys, I hope that helps us out just a little bit.